Welcome to Web Handling. My name is Dave Roysum. I am super excited to continue the series on Rewinder and R2R converting machine productivity. In this short clip, we will introduce a person who has a very large influence on productivity, the operator. The motivation for this section is simple. There may be more human-machine interactions on your winders than most any of the other machines in your plant. Just as you want to keep your machines in good working order, you also want to keep your operators in good working order. Some of this relates to job-specific training, while some might be related to aptitude. But here, we will consider attitude. The very least we should do is treat operators as we would treat a stranger. Better yet would be to treat them as equals. However, to get the most from operators, I would suggest treating them as your superiors, at least in some ways. In general, operators should know how to run their machines better than anyone else, including you. If not, something may be wrong, because that is their job. There are many case histories of unions going on strike and where the engineers and supervisors were forced to run the machines. It was not pretty for weeks and sometimes even months. Another thing to consider is that operators spend more time at the machine and thus may notice more things that might be indispensable for problem solving. In my travels as a troubleshooter in 1,000 plants, I cannot count how many times a critical observation for problem solving came from an operator. Without their input, the problem solving mission would have likely failed. Nobody likes a know-it-all, even if they know a lot. Some humility is helpful even if you purchased, designed, installed, or started up their machine. Also, be sensitive to when you intrude on a process. Sometimes are better than others. Another thing operators hate is targets. True, sometimes targets may have their place. However, this does not make them more attractive in the eyes of someone who may already be trying to do their best. Another thing operators hate is paperwork, because they suspect that some of it is just busy work. Guess what? Much of it is. Most data is never, ever used by the process engineers who originally requested it. There's a saying that if mama ain't happy, ain't nobody happy. This also applies to operators. If they are not happy, or at least satisfied, no one will be happy, including supervisors, CEOs, and the board of directors. Job-specific training is vital. Even the simplest winder has as many controls as a light aircraft, and a coder laminator could have as many knobs and dials as a small jet airplane. Yet, as important as formal training is, it is often not available. Most training is done ad hoc, where the last operator teaches the next, and so on. After only a few generations, the operators might not even know the names of the parts of their machine. Formal training for converting machines is generally available only from two sources, each with their own pluses and minuses. The OEM, or machine builder, might supply training that is specific to that make and that model of machine. Here we are dependent on the skill and the effort of the builder to construct a useful combination of classroom training and hands-on training and, most often missing, training materials. Yet, done well, this training may be the best for some situations because it is tailored to a particular machine. Unfortunately, training such as this is rarely offered and even more rarely purchased. In contrast, generic training is available from consultants and other sources. Here, the level of presentation is usually more technical. Also, the teacher will use generic names, such as nip load, and expect that the student be able to envision or translate that label or that word to a specific setting on their machine. The result is that generic training puts higher demands on the student than does machine-specific training. There are many best practices to improve communication. Perhaps the most overlooked is the logbook. Here, operators record issues that can be used by other operators, management, and troubleshooters alike. Another is to have a smooth handoff of two shifts where both overlap for at least 15 minutes so that the shift just finishing can share information on recent troubles to the new one so they don't have to struggle unnecessarily. Regular department meetings involving operators is helpful for a variety of topics, from safety to best practices to upcoming changes in the department. If there were anything that summarizes the ideas of the last couple of slides, is that full respect and participation of operators is in everyone's best interest. There seems to be a never-ending battle with mythology in many plants. Some of this has to do with the lack of training, but other times it is just the natural tendency for people to oversimplify what can be complex systems. Black and white thinking can be counterproductive. Consider the common myth of, do you want it fast or do you want it good? It is entirely plausible that rushing can sometimes contribute to certain poor results. Consider winder speed as a very specific case. Sometimes higher speeds coupled with brittle web breaks might cause web break cleanup time to increase, thus reducing overall productivity. Another example is increasing speed might sometimes degrade roll edge quality. Yet, the exception to the rule are even more common. In most cases, increasing winder speed will increase productivity. In most cases of winder defects, speed has little or no effect on defect rate or severity. In fact, some defects actually improve with speed. A common example is wrinkling, which tends to decrease in frequency and severity as you go from thread speed to 100 meters per minute or more. The problems with many of these plant myths are logical fallacies. The first fallacy is that true dilemmas, meaning that there are only two choices, are quite rare in the real world. How about fast and good instead of fast or good? The second fallacy is that the general rules, even ones with sound scientific foundations, have many exceptions in the messy world of web manufacturing and converting. The productivity and product quality coming off a winder does depend to some extent on the attitude and aptitude of the operators. There are many subjective hints on how well they are doing, yet I think most of us would prefer an objective measure of operator performance. However, before we start with things that might work, let us start with things that may not work so well at all. The most obvious would be to try and compare shifts. Sometimes you might find the night crew is less productive. But that could be beyond the operator's control because there is less supervision and less resources, and people working at night or rotating shifts are in perpetual jet lag. In other cases, the day crew might be the slowest, and that could be due to interference by engineers or management. Similar issues can happen by comparing overall defect rates. Instead, I would like to propose some objective metrics that are unique to the skills of a particular operator. The first is the time to change a set or master roll. The second is the defects that only an operator could be responsible for. An example is setting the slitters incorrectly or getting the wrong roll width. The layout of the winder area can have a large influence on productivity. Desirably, aisles are straight and wide so that operators and maintenance alike can easily service the machine. This is best done when a plant is laid out and the machines are installed. Yet, even after the fact, you can squeeze more productivity by getting crap out of the way that is seldom used. One example is parts and odd supplies. Another common example is control boxes and piping that impinge on a walkway. Perhaps my favorite management program of all is 5S. It can be summarized as everything has its place. It is important not to make an operator unnecessarily uncomfortable. Perhaps the simplest yet often overlooked are floor pads for standing and armless padded chairs for sitting. However, sometimes it is possible to make the operators too comfortable. A common example here is the control room that can distance the operator from his or her machine and product. Waste is a fact of life. Dealing with waste gracefully should be brainstormed as much as you would product or supplies. Since I've never seen anyone wear sunglasses in the some 1,000 plants I've been to, it is probably safe to assume that there is not too much lighting anywhere. Instead, there is an epidemic of grayness and gloom in many plants. Perhaps it is due to an energy crisis, or perhaps it is causing an energy crisis. In any case, there are many practical reasons to improve lighting, such as to improve web inspection, roll inspection, reading paper, reading tape measures to set slitters, and so on. You might be able to buy a bank of lights for the cost of just one single wrong roll width caused by poor lighting. Details matter, of course. Adding more overhead lights is not always the best situation because of the shadows cast by in-between frameworks and other machine elements. Instead, local diffuse lighting tends to work much better. Operators tend to perform better when machine elements help rather than hinder their efforts. No place gets more time and traffic and thus demands more attention than the benchboard or operating panel. A good benchboard allows comfortable operation while sitting or standing. Vertical panels, and especially ones that block the view of the machine, may not be so helpful. Chairs should be comfortable, but easy to get on and off. Floor pads greatly reduce fatigue, but can be tripping hazards unless they are beveled and have a good color contrast to the floor. My WEb201.51a through D series on this all web handling channel of YouTube covers the operator station in much greater detail. If it looks like your control screen or control panel was designed by people who haven't operated machines before, you would probably be right. What we expect, at the very least, is good organization. On panels that have full graphics capability, putting up a schematic of the web line first can help force organization by putting I/O right next to the element that it corresponds to. One area that's almost always overlooked is a simple shelf for writing, because paperwork will be with us for most of the time to come. True, people improvise, but the results are not nearly so pretty as if they were built into the panel to begin with. My WEb201.51a through D series on this all web handling channel of YouTube covers control ergonomics in much greater detail. Thank you so very much for allowing me to share this brief treatment of Rewinder and R2R converting machine productivity. Stay tuned to this all web handling channel for even more plant practical troubleshooting clips. Please like and share if you found something interesting or useful. See you next time.